Number 68. During forced exhalation, such as when blowing up a balloon, the diaphragm and chest muscles create a pressure of 60 millimeters of mercury between the lungs and chest wall. What force in newtons does this pressure create on the 600 squared centimeter surface area of the diaphragm? So in terms of this one, right, it's actually very simple, right? Think about what we're given. We're given pressure, we're given surface area, and we're asked to find force. So what equation relates those three variables together? Oh, look, it's this one over here on the right-hand side. Right, pressure will be equal to force applied divided by the area over which that force is applied. So if I want to find force, solve for force, just cross multiply basically. So it's pressure times an area. Okay, great. We know the area. Now I want to use standard units in here because I want to find it in terms of newtons. Okay. And they tell me the surface area in squared centimeters, so we're going to have to convert that into square meters. Another thing is they tell me the pressure, right? And we need this in terms of Pascal, and we don't have that in terms of Pascal. We have it in terms of millimeters of mercury. So there's two things we need to do. So firstly, how do we convert millimeters of mercury into Pascal? Either you know the conversion, or you might be able to do it this way. And this formula over here on the right-hand side relates pressure to the height and density of a certain fluid. So look, you have a height, 60 millimeters, right? And you have mercury. So there's a certain density of that mercury. So what I'm going to do is I'm going to substitute on in this H rho G in for the pressure. So it's going to be the height of the mercury multiplied by the density of the mercury multiplied by gravity. This will now give me, as long as I have my standard units in here, this will now give me my pressure in Pascal, then multiplied by my area again in meters squared. So now let's just plug in some of the values. So what's the height of the mercury? Well, they told me it was 60 millimeters, but I don't need millimeters, I need meters. So plug that in as 0.06. Okay, 0. Then multiplied by the density of mercury. What is it? Well, you need it in kilogram per cubic meter. You can look that up, or you might be doing enough problems where you're memorizing it. It's going to be 13,600 kilogram per cubic meter. Multiply that by gravity. That should be fine at this point. And then multiplied by the area, but we need to convert that into square meters. So I'm actually going to do the conversion in the problem, right? So we're going to have 600 centimeters squared. And all I now need to do is basically centimeters on the bottom, meters on the top, 100 centimeters for every meter, but then you got to square this result so the centimeters will cancel fully, okay? So that should be it. Now we can just calculate, all right? So basically it's going to be, this portion here is 600 divided by 100 squared. That's basically what that's going to work out to be. So this is 0.06 multiplied by 13,600 multiplied by 9.8 multiplied by now 600 divided then by 100 squared. And we had a value here in terms of Pascal of 480 if we consider rounding with 3 sig figs and whatnot. 480 newtons. So that would be the pressure. That would be the force that's created by this amount of pressure and over this particular surface area. Guys, thanks for tuning in. I hope this helped. Please remember to subscribe, and we will see you next time. Take care.